Alright, so we have a box. So let's roughly sketch out this box. Okay, so you will look. We use parallel lines to make it look really nice. Okay. Okay, there you go. So the box is open on the top, and we want to know what is the largest possible volume for this box. Okay, so let's label the dimensions of the box. Let's call this x, x, y, and h for height. So the first thing you have to do is, what is it that we're trying to optimize? Okay, it's almost always in the final sentence, and it's the volume. So the volume, right, is from the diagram, it's x times y times h. Okay, and we have three variables here, and this is not good. To one variable, so it's a function of one variable, so we can differentiate and find the critical number. So let's read the question carefully. It tells us, first of all, it's a square base, meaning x is actually equal to y, and it has a surface area, right? The material means surface area of 1200. So if this is actually x, right, the surface area is x squared, and this front here is just x times by h, but there's four of those, right? This is equal to 1200. And you can see that you can easily isolate the h. Okay, so let's do that. 4x h. And then you isolate the h by dividing both sides by 4x. Okay. So volume as a function of x now will be x squared times by h is this, right? Okay. Let's reduce the x, and we get x times by over 4, but I'm just going to put the entire thing over 4. In fact, it's actually better because we don't need to consider the constant at the bottom, so we can just put the 1 over 4 at the front like that instead of at the bottom. And to find the maximum volume, we need to differentiate. Okay, let's leave the quarter out at the front. Let's differentiate x, and you get 1. Right. Plus, right, leave the x, differentiate that, and you get minus 2x. Okay, so you gotta set that equal to 0 to find the critical number. So you have 1200 minus x squared minus 2x squared is equal to 0. Okay. So to find the critical number, we have to set what's in the bracket to be 0. You can factor out a 3. You get 400 minus x squared is equal to 0, which means x squared will have to equal to 400, which means x is equal to plus minus 20. But of course, we're talking about a geometry problem here, so we don't need to consider the minus 20. Okay. So how do I know that x is equal to 20? X equals 20 will actually give you a maximum volume. Well, we have to visualize. Okay, we have to visualize this picture, and it's just easy picture. It's a parabola that's going upside down with roots at 20 and minus 20. Right before 20 it's positive, right after it's negative. That means the graph is going up and then down at x equals 20, so it's going to be a local maximum. Okay, so possible volume, let's plug it all in here now. I'm just going to put up here, therefore max volume is equal to 1 over 4, 20, 1200 minus 400, 5, 800, that's 4,000. So 4,000, the unit was centimeters, so it's centimeter cubed.